Very good afternoon to all of you. I am Dr. Shubhodip Gupta, Assistant Professor, Department of Geography, Asutosh College. Invite you all on behalf of my esteemed institution, Asutosh College, in today's webinar on fundamentals and applications of remote sensing and GIS. On behalf of Department of Geography, I would give heartfelt thanks to the authority of Asutosh College and Balurghat Mahila Mahavidyalaya for organizing jointly this program. Today, we are going to hear Dr. Tathagata Ghosh, who have already joined, Assistant Professor, Department of Geography, Balurghat Mahila Mahavidyalaya, Dakshin, Dinajpur, West Bengal. He is also the head of the department of this college. Welcome you, sir. I welcome you on behalf of my department in today's webinar, which is jointly organized by Department of Geography in collaboration with IQAC, Asutosh College, and Committee for Postgraduate Studies. Today's program comes under the Faculty Exchange program under MO between Asutosh College and Balurghat Mahila Mahavidyalaya. I am privileged to introduce today's speaker, Dr. Tathagata Ghosh. Dr. Tathagata Ghosh has been actively working in the field of groundwater hydrogeochemistry for last 14 years. His areas of expertise are geospatial analysis, groundwater contamination, hydrogeochemical analysis and interpretation, application of GIS and remote sensing in crop phenology and geostatistical analysis. He did his PhD from MS University of Vadodara, Gujarat, India, and on groundwater arsenic contamination in West Bengal. He is engaged in teaching geography at UG as well as PG level for last 10 years. He has already completed one ICSSR funded major project as co-PI. Till date, he has produced more than 20 national as well as international research publications indexed in Scopus, Web of Science as well as UGC care list. A few publications are listed below. Recent sedimentation across Kori Creek in the western Great Run of Kutch Basin, insights from tidal network changes, sedimentological, clay, mineralogical and rare earth element studies, 2024, Journal of Coastal Research. Evaluation of spatial temporal dynamics in agriculture in arid and semi-arid region of Rajasthan, India, a statistical approach, 2023, Journal of Applied and Natural Science. Agricultural land susceptibility categorization and evaluation using GIS assisted AHP in the arid western plain zone of Rajasthan, India, 2023, India, Journal of Agricultural Research. Appraisal of long-term responsiveness of normalized difference vegetation index to climate factors using multi-scale time frequency decomposition in an arid environment, 2023, Frontiers in Earth Science Frontiers. Geospatial evaluation of cropping pattern and cropping intensity using multi-temporal harmonized product of Sentinel dataset on Google Earth Engine, 2023, Applied Sciences MDPI. Aquifer vulnerability assessment in the Bengal alluvial tract, India, using GIS-based drastic model 2026 modeling Earth system and environment Springer. Geo-environmental appraisal of groundwater quality in Bengal alluvial tract, India, a geochemical and statistical approach 2014 environmental Earth science Springer. Currently, he is working as an assistant professor and HoD, Department of Geography, Balurghat Mahila Mahavidyalaya, Balurghat, Dakshin, Dinajpur, West Bengal. So now, let me introduce the topic of today's lecture. It is the fundamentals and application of remote sensing and GIS. Today's lecture is going to emphasize on the introduction of remote sensing, GIS and GNSS, the sensor, orbit, resolution, scanning procedure, etc. Type of remote sensing, digital image processing. It will emphasize on raster and vector modeling, global positioning system, GNSS, integrating of RSGIS and GNSS, that is geomatics, cloud-based remote sensing and GIS, application of artificial intelligence and machine learning, use of Google Earth Engine, application of RSGIS GNSS. With this brief note, I am transferring mic to today's respected speaker, Dr. Tathagata Ghosh, and inviting you, sir, to deliver your valuable lecture. Thank you, sir.
Good afternoon to all. I'm privileged and honored to be a part of this type of program. So already, sir has already given the introduction about the program, about myself. So without further ado, let's focus on the topic. Let me just share the slides with you. Just a minute. Okay. So, today's topic is fundamentals and applications of remote sensing and GIS. Before going into the detail, let me just show you the first slide. The slide shows the quantum computer that right now Google is working on. Now, my basic apprehension about this machine is right now we are having personal computers, we are having laptops, we are having very high-end processors right now. Now the question is, why is it so that Google is developing this type of computer? Because over the time period, the nature of the problem is changing. Over the time period, the problems are becoming so complex that the traditional computers and traditional machines are unable to solve those problems in a specific time period. That is why over the time period, we need to change our approach. Likewise, when we are talking about remote sensing and GIS, unless and until if you are understanding the basics, if you are understanding the fundamentals, it will be really possible for us to answer the real world complex issues. For example, right now our Earth is experiencing relatively higher temperature. West Bengal is having number of places, number of districts with red alert and as well as orange alerts. But question is, if we want to solve these issues, we need to have some basic understanding about the meteorology first. Then we can have certain solutions. Likewise, when we are talking about the applications of remote sensing and GIS, firstly, we need to have thorough idea about the processes that is happening underneath. Then and then only we can understand its applications as well as probable solutions. So as a geographer, we always focus on mapping the world in different ways. Initially, it was like our own perceptions, and through that, we have mapped our world. In front of us, we are having really primitive map. But at that time, major issue was it was really difficult to make any kind of ground checking, because at that time the availability of the resources was not there. So what we did, we started using different types of tools, like different conventional tools like the theodolite, sextant, or dumpy level. And over the time period, we have made certain changes and most modifications into that, like we are right now using total stations, we are having different GPS and so on and so forth. But what has not, over the time period now, it is the age of digital mapping. Digital mapping means where we are not relying on the traditional methods only. We are incorporating different types of tools and technologies that can answer really difficult questions in a specific time period. But what has not changed over the years is the data. Before starting any work or before starting any giving any answer to any problem, we need certain type of data with us. With that particular data collection is the major question, how to collect the data. If I'm going through different types of traditional data collection methods, like for example, if I'm going through different types of field survey, it is possible to work in a specific area, let's say in a micro scale. But when we are talking about the macro work, let's say we want to understand what has changed over the last 10 years in terms of the vegetation over the earth, then it will be really difficult for us to collect the data, because the spatial extension is too much. In that way, the traditional method only is not going to work. We need to take help of other resources. And here comes the applications of remote sensing. Here in this particular slide, here I am collecting the data from parts of Murshidabad during my PhD. It is one way of collection of the data. But if I'm talking about other sensors which are available with us, for example, our eyes, our ears, binoculars, or for example, any imaging product like camera, they can also collect the data, but their approaches are different. In one side, I'm talking about a physical entity, collection of groundwater. In other side, we are talking about different approach or different segment of the same thing. Now, if I'm talking about the definition of the remote sensing, it is very easy. Remote and sensing. Sensing something from a remote place. That is the basic ideology behind the remote sensing. Now, question may arise, why we need to sense something from the remote place? Why can't we visit the particular area physically? The answer is very simple. Yeah, hello.
Slide is not changing.
Okay, just a minute.
Just make it full screen after that.
Yeah, is it visible now?
Not in full screen mode.
Whenever I'm going to the full screen, the screen is not changing. However, let me just increase the size right now because.
Okay. You please share the entire screen in Google Earth, in Google Meet.
Just a minute.
If you click on option the entire screen and during sharing the screen, then it will appear.
Okay. Now is it visible, sir?
No, it is not visible.
Entire screen, okay, share.
When you're sharing your screen, you go for the entire screen and click on the window of entire screen.
Yeah. Now, is it visible?
No, not at all. No, in YouTube window, I can't see. Now it is visible, I think. But it is only partly visible, not in full screen.
Okay.
Now it is visible.
Okay, okay. So, now the slide is changing, right?
Yes, sir.
Okay, okay. So, if I'm talking about the term remote sensing, that simply means sensing something from the remote place. And as I have already told you, that it is not possible for us to reach every part of the world because it is some of the places are really remote. In that particular context, we started understanding about the process through which we can reach those places which are unreachable. And remote sensing can give us that particular facility through which we can collect the data from those remote places. So we can say remote sensing includes all the methods and techniques used to gain qualitative and quantitative information about distant objects without coming into direct contact with these objects. So what are the questions before going into the detail of the remote sensing? Remote sensing tries to answer these questions. How much of what is where? What is the shape and extent of that particular thing? Let's say area, boundaries, or lineaments. What has changed? What has changed over the time period? What is the mix of these objects? So these are the things that remote sensing always tries to answer. And in the coming slides also, we are going to see same kind of aspects throughout. Now, if I'm talking about brief history about the remote sensing, we have started our journey very early, as early as 1859. For example, we have used balloons, and from that we have tried to take a picture from the specific height. In 1862, US Army balloon corporations, they have also tried the same thing. Over the time period when our technology started developing during the World War, we have used aeroplanes through which we have started taking pictures of the Earth's surface. Now, if I'm talking about entire gamut of this remote sensing, GIS, whatever, then we can understand it is a combination of number of aspects like physical science, social science, as well as biological sciences. And remote sensing, geographic information system or GIS, and cartographic or surveying techniques, they works together. And at the center where the star is there, it is the place where everything started mixing up with each other. As a student of geography, I always know that geography is a kind of subject where it always tries to take everything into association, and GIS, remote sensing, and cartographic techniques, geostatistics are also like that. It is not like that remote sensing is going to single-handedly give you the answer to the problem, or geographic information system when you take everything into association. So if I'm talking about the remote sensing, it is having different parts. For example, the mission plan and the choice of sensors, the receptions, recording and processing of the signal, the analysis of the data, and the resultant data. Now, these first two things, that means A and B points, that would be there in the producer's end. Most of the cases, we are not bothered about that particular part. But the third one, that means when we are at the end, that means we're trying to analyze whatever we are getting from that particular data. Here we are concerned about. Now, if I'm talking about the entire process of the remote sensing first, in this particular diagram, we can clearly observe that there are several segments of the remote sensing process. For example, if I'm talking about the source of light, sun is one of the major source. When the sun rays is coming from the atmosphere to the earth, it is interacting with the earth's surface. Some of the part is absorbed and some of the part is going through the atmosphere, and again it is absorbed or it is sensed by the sensors present in the satellite, that is there in the D position of this particular diagram. Now, it is not always necessary that we need sunlight for remote sensing. We can have different other sensors which can work without the source of light. For example, active remote sensing, that we are going to talk in the next slides. Now, when the sensor is going to capture the image or capture the different type of signals that is bounced from the Earth's surface, it is sent back to the ground where we are going to process it. Now, when the processing is done, we are going to get the final map out of it, or image out of it, or photograph out of it. And finally, we are going to make certain type of analysis out of that, and we can have different applications of that. Now, before going into the detail of the further aspects of the remote sensing, let's focus on some part of the physics of the remote sensing. When we are talking about the sun, it is associated with the solar radiation. And the solar radiation is associated with the electromagnetic character. Electromagnetic character means it is having both the character of electrical as well as the magnetic. Now, as we know that electrical signals and magnetic signals, they work in more or less perpendicular to each other. And if I'm looking at the wave itself, it is having different character. For example, if I'm talking about this particular first diagram, where we can see there is a very long wavelength. That means from one crest to another crest, or one trough to another trough. The distance is called the wavelength. In some places, you can see the length of the wave is relatively smaller. Here it is much smaller, and here it is very narrow. So that means based on the distance between one crest to another crest and one trough to another trough of these waves, we can judge whether that is a long wave or a short wave. Now, when we are talking about the next thing, which is, I think, considered as the most important aspect of the remote sensing, that is called the electromagnetic spectrum. What is the meaning of electromagnetic spectrum? When we are talking about the sun rays coming from the sun to the earth, only a very small part we can see, and those colors that we can see, they are called as the primary colors. In other words, they are also called the visible band. That means this part we can only observe through our eyes. But there are several other parts of this entire solar energy coming to the earth. And if I take all of them together, then it would be considered as electromagnetic spectrum. For example, we are having gamma rays, X-rays, ultraviolet rays, as well as we are having relatively bigger wavelengths like microwave, radio waves. And here, this narrow part we can only observe. For example, this particular region which is known as visible spectrum, where the primary colors like blue, green, and red are there. Now, the next important thing that is known as signature spectra, or it is also known as spectral signature. Let me explain to you what is the meaning of this particular slide. Now, if I'm talking about an instrument that can absorb as well as that can reflect the energy. Now, you are targeting it that towards a green leaf of a vegetation. Now, what will happen? It is going to give you certain reflectance. So, if I'm talking about this particular slide where the x-axis shows the wavelengths and the y-axis shows the reflectance, here 0.4 to 0.5, 0.5 to 0.1, 1.5, 2 and 2.4. And now, if I'm talking about this segment where color is given, this is the visible band. That means our eyes can see. If I ask you, okay, what is the color of the green of a leaf? You would say that is green. What is so special about it? But if I'm talking about this yellow line, that is the signature of a green leaf. What it shows? It shows that in a specific region, that means near 0.5 to 0.6 micrometer, this particular segment, we have a peak, but we have much higher peak in the region which are farther away from our visible region. That means near infrared region. That simply means if I'm talking about the green vegetation, its reflectance is much more in the region which is not visible through our eyes. Our eyes can see this particular segment, that is from 0.4 to 0.7 micrometer, and our green area is showing this much of reflectance. That is why it is the green leaves are the leaves are appearing green. But the problem with our eyes is that we can't see infrared through our naked eyes. That is why if I'm talking about every element on this earth surface, if I'm using those particular type of instrument to understand its reflectance in terms of the wavelength, then we are going to get certain type of signatures. For example, vegetation, water, as well as soil. And these signatures are already calculated on thousands and millions of samples. And based on that, we have created a database. Through that only we can teach the machine that whenever this type of reflectance or this type of spectra would come, you judge it as a green vegetation or you consider it as a soil. Now, let me tell you about some small idea. That means you need to understand that what is the meaning of atmospheric windows. In certain places of our atmosphere, it is working like a transparent regions through which the electromagnetic radiations can come and move out freely. But in certain regions, there is a blocking effect of our atmosphere. That means through that, these electromagnetic radiations, the temperature can come, the light can come, but these type of energy which are coming to the Earth's surface, it is coming with the restricted regions of the wavelengths. That is why in those areas of the atmosphere from where the energy can come freely, those particular zones are known as the electromagnetic spectrum. You can ask me, why is it so some part of the atmosphere is blocking this type of electromagnetic radiations? The answer is simple, due to availability of the different types of gases of our atmosphere and the composition of our atmosphere. Now, the same thing that is there that we can observe on this presentation. Also here, one important thing that you need to understand, that is FCC, or false color composite. Now, problem is, as I told you, that the green vegetation is showing peak in the infrared regions. But question is, can we see it through our eyes? No, we can't see infrared through our eyes. So what we can do? We can give it a specific color. through which we can observe that that these are the vegetations. Because if I'm going to give it a green color, that might not give us the proper idea about the vegetation. So when we are giving this infrared region with the alternative colors, then it would be actually known as the false color composite. There are different schemes, that is standard false color composite, and number of types of compositions are there. Now, next thing that we need to understand, it is known as the resolution. This term is not very much new to us, because resolution, we deal with this resolution term day in and day out. For example, what is the resolution of this particular camera? What is the resolution of this picture? What is the resolution of this TV? And so on and so forth. In that particular ways, we can say that resolution is a type of condition where we are trying to understand how a particular sensor, how a particular detector can differentiate between two objects. What is its efficiency? For example, if I'm talking about this particular slide, you can see that we are having similar region, but the region's area coverage is changing. For example, it is 0.5 by 5 meter, it is 5 by 5 meter, and it is 40 by 40 meter. You can see as the area coverage increases over the time period, it is becoming pixelated. Or we can say when we are actually decreasing the pixel per inch, that means how much pixels are there, how much dot is used to prepare this particular image is decreasing, its resolution is keep on decreasing. That is why in those maps, in those images where pixels are more, dots are more, obviously the image is going to have lot more information in that. But as the information, that means these dots and pixels are decreasing, this information is also going to decrease. Now, let me ask you, let us have a very small discussion over this particular slide, because let's say we are having a camera which is almost like 5 lakhs of rupees, which is only having 24 megapixel. This megapixel term is also very much common to us. And we are having very small camera like this, which is a pocket camera, which is also of 24 megapixel, and it costs only about 20,000. Now, question is how come? That means one camera with the similar capacity is having the similar price to the very small camera. The answer lies within, that is the sensor that is used in both the cameras. The sensor is one of the most expensive part of any camera, whether you are talking about a handheld camera or you are talking about any type of camera used in the satellites also. As the sensor size increases, its price also increases. As the sensor size increases, its capacity to organize the pixel is also going to increase. Suppose we are having very small piece of sensor in this particular camera, and we are trying to fit a similar 24 megapixels, and here we are having really big sensor and we are trying to fit 24 megapixel. What would be the difference between both? The difference would be, in this particular camera, the pixel organizations would be much better than this camera, because this area coverage would be smaller and it will not be possible for us to organize it very proper way. That is why as the sensor size increases, its capacity also increases. That is why when we are talking about any kind of satellite images, sensors plays a very important role. Now, the next type of resolution is known as the spectral resolution. The spectral term came from spectrum, or the light or color. That means when we are talking about a specific type of resolution, where resolution, that means sensor's ability to distinguish between different colors is concerned, then it would be considered as the spectral resolution. For example, when we are talking about a black and white film, it is from 0.4 micrometer to 0.7 micrometer. And if I'm talking about a color film, it also ranges from the same 4.4 to 0.7, but the difference is, in black and white film, the blue, green and red, all of them are with each other. That means there is no differentiating borderline between these colors. But if I'm talking about the color film, where blue, green and red colors are individually processed, that is why the mixing of green to red, blue to green, blue to red is possible. But when we are talking about the black and white film, all of them are together. That is why it is really difficult. If I'm talking about the spatial spectral resolution, as the amount of wavelength concern increases, its capacity to hold more and more color, more and more information is possible. Now, the next important resolution is known as the temporal resolution. Temporal resolution means how often that particular sensor or that particular satellite is going to take the picture. For example, if a satellite is taking picture on 2nd July, 18 July and 3rd August, that means 16-day difference. If another satellite is taking picture 1st July, 12th July, 23rd July and 3rd August, that means 11-day repeativity. That means we can say this particular satellite with the 11-day repeativity is going to have better temporal resolution than this one. In the next coming slides, I'm going to show you certain of the satellites. For example, Kalpana satellite is one of the most important satellite that is concerned with the atmospheric condition. That is going to take, that actually takes number of images per day. That means its repeativity per day is more. So in that case, is temporal resolution would be more. Now, the last type of resolution is known as radiometric resolution, where in case of spectral resolution, we are concerned about the colors. But in this radiometric resolution, we are concerned about its intensity. For example, if a specific type of region is associated with 6-bit range, that means bit means that can accommodate 0 to 63 type of binary products. At the same time, 8-bit range 0 to 2555, 10-bit range 0 to 1023. That means if I'm talking about this range of accommodation of the intensity or the brightness of that particular component, then we are calling it as a radiometric resolution. As the bit increases, as its intensity increases, obviously its resolution is also going to increase. Here in the lower portion of this slide, we can easily observe that as the resolution, that is bit resolution, decreases, we can see it is becoming lesser and lesser intense. Its brightness decreases and we cannot distinguish between these things. For example, here at the mountain top, we can observe different segments clearly. But in this particular one, we can only see black and white. But in this particular first image, we can say it is having different shades of grayscales. That is why radiometric resolution is also very important. Now, there are different types of remote sensing. For example, aerial photography, multispectral, active and passive microwave, as well as LIDAR. Here, there are different platforms through which we can take or we can observe the Earth. For example, we can take images from the Earth surface itself through camera. We can have a kind of elevated part through which we can take the picture. We can have airborne sensors, for example, through aeroplanes, through drones, through other low altitude flying machines, or we are having sensors which are actually there at a very higher altitude. That means depending upon our need, we can have different platforms. It depends what is your problem, how much area you want to cover, how much detail you want, what is the repeativity you want. Based on that, we can select the layers or we can select this particular type of platform. Now, if I'm talking about the first one, that means aerial photographs, it is considered as one of the most primitive data products of the satellite, data product of the remote sensing, that is known as the aerial photograph, where initially we tied the smaller cameras at the feet of the pigeons, and you can see the photographs that is taken by the pigeons. What we did, we just trained this pigeon to fly from a place to another place, and these smaller cameras, they are time-lapse cameras, like they are going to take automatically photographs at a specific time interval, and when they come to the destination, we can develop the photograph and we can see what is happening on the Earth's surface. Over the time period, it has changed its nature. Nowadays, we are having very high resolution aerial photographs also, and through different platforms we can take it. Likewise, this is a Leica. It is one of the high-end cameras through which we can take the aerial photographs. This is one of the example of the aerial photograph. And if I'm talking about the basics of camera, how it works, as we know, in DE plane we are having the camera where we are having the particular film which is situated at the C point. This is the lens, and AB, it is the Earth surface. Now it is more or less perpendicular and it is trying to take the picture of A, B sections. Now depending upon different conditions, we can have different parameters of the aerial photographs also. Aerial photographs are associated with different terms like focal length, flying height, nadir, flight line, stereoscope and fiducial marks. Focal length means the distance between the camera lens and the film. Flight height, the height through which that particular aeroplane or the particular flight is moving. Nadir, the point just directly below that that particular lens. Flight line, the path through which the flight is moving. And the stereoscope, it is an instrument through which we can analyze the aerial photographs. And the fiducial mark, I'm going to show you in the next slides. This is the basic way through which the flight moves from one place to another place to take the picture. One of the most important thing is that here you need to understand the two photographs, when we're going to side by side put it, they are going to have 60% overlap. It should be there. Otherwise, the aerial photograph is not going to give you the proper outcome. That means when a flight line is moving in this particular way, it is going to give you these photograph and this photograph, they're going to have a 60% overlap. But when you are talking about the vertical arrangement, there should be 30% to 20% overlap. And in this way, when a flight line moving in this particular part way, the area is going to cover. Now, this is a pocket stereoscope, and these smaller points, that means at the edge of this photograph that you can see, they are known as the fiducial marks. These fiducial marks are used to align both the aerial photographs to have the three-dimensional observation of this particular region, because this stereoscope can give you the three-dimensional view of this particular aerial photograph. Now, it can be high oblique, where the obliquity will be more, where it can be low oblique, where the obliquity can be lesser. It depends upon your need, how, in what way you want it. Now, these are the other aspects also. Now, if I'm talking about the satellite images, now question may arise, if we are having aerial photographs, then why we need to have a satellite image and satellite? So, because one of the major issue with these aerial photographs is its availability and its expense. It is really expensive because it is not possible to have photographs of all the places. For example, I belongs to the region, let's say Balurghat region, and I want to work in the Balurghat region. It is not always possible and feasible to have the aerial photograph because it might be not available also. So for that issue, we have started relying on the satellite images. As we know, there are different types of satellites, and based on our need, we can have different aspects. So broadly, we can classify the satellites into two dimensions, two aspects. Number one is geostationary, and number two is sun synchronous. Now, what is the meaning of geostationary? The term geo and stationary means these satellites are stationary to the Earth's rotation or the Earth's rotational velocity. The distance from the Earth's surface to the satellite is relatively larger, like for example 35,900 kilometers. And second one, that is known as the sun synchronous, its height is relatively lesser, almost 1,000 kilometers. They are also known as the polar orbital satellites. Now, these polar orbital satellites and this geostationary satellite, both are having different purposes. One is there nearer to the equator. For example, our Indian satellite like INSAT, it is there nearer to the equator of the Earth, and its purpose is different than those of the polar orbiting. We are going to discuss about in the next few slides. And here I try to show that when a satellite is moving in this particular path, for example, is polar path or the near polar path, it is going to cover a specific region. This particular strip would be considered as the swath. It is known as the swath of that particular satellite. And when the satellite is going to complete one revolution around the Earth, it is going to change its position and it is going to take another satellite. It might also possible that we can use more than one satellite to take the Earth observation in a single time period. Now, there are different types of satellites still there available. For example, we are having 1,100 meters resolution NOAA, AP, HRR. We are having GIS 700 meter. We have MODIS, Landsat, Spot, IQAC, as well as quick bird satellite images. But one thing you can observe that as we're moving down, its resolution, it is a spatial resolution that we are discussing about, it is keep on decreasing. That means if I'm talking the quick bird satellite image, it is having the resolution of 0.6 meter. Obviously it is really expensive one, but if I'm talking about its clarity, its resolution, it is marvelous. Now, if I'm going to move through quickly through different image interpretation or the elements associated with the image interpretation, the first one is the shape. For example, if I'm talking about this satellite image or aerial photograph, shape plays a very important role, where in this particular one we are having a aeroplane, here we have a pentagon, and here we can see the road structures as well as the vegetation. At the end of the slides of these particular elements, you will understand why I am differentiating or I am emphasizing too much on the shape or the shadow. Now, if I'm talking the second aspect, which is the part of the image interpretation, that is known as the shadow, which is very much important. Because let me show you this particular one. Let's say cars are moving in this way and another car is moving in a different direction. Now, just think about the situation. If this shadow position was not there, then what would happen? Then it would be really difficult for us to distinguish that at what level these cars are moving. Here we are having a kind of flyover, which would not be possible for us to detect through the satellite image or any kind of product, aerial photograph might be, if this shadow was not there. And that is true for these two images also. Now, tone and color, that's radiometric resolution that I was talking about. How much amount of intensity of light is available there? Depending upon our need, we can change the tone and color of the image also. For example, if I'm talking about these three images at the top, all of them are showing in the same thing, but their representations are different and their uses are different. Because if I'm talking about the first one, you can see it is more or less washed out. But if I'm talking the last one, every element can be observed very properly. Here you can see some of the channels can be seen, but here these channels are very much properly seen. So that means tone and color is another aspect of the satellite image or the aerial photo interpretation. Now the texture, based on the character of the texture also, we can distinguish between the objects. For example, here the texture and here the texture are totally different. So we can easily observe that we can say that this particular region is as to the different type of vegetation, and here we have a totally different vegetation, or might be grassland or marshy regions. Here we can see the similar kind of vegetation, similar type of pattern can be observed, and that is true for the other images also. Now the pattern, here the pattern means here we're trying to understand what type of pattern this particular region. Here we can see linear settlement patterns with number of settlements available. And this is only possible to see through the satellite images or aerial photograph, because if I'm looking it from the front side or I'm standing on the road, it would not be possible for understand or observe the patterns of that particular region. Height as well as depth. And last important aspect of the satellite image or the aerial photograph is the height. Here, if we are trying to understand the height element or the aspect of this particular region, just look at this particular pillar. If the shadow was not there and only the pillar was there, then it would be really difficult for us to distinguish between the heights of this particular region. And lastly, the association. Whatever images I have shown you, all of them are together now, and you can all easily observe the different association between different objects present in this particular region. So these are the different elements which are associated with the image interpretation. And these are few other examples also. Now let's move into the satellite images. The satellite images, nowadays, they are very much popular because of their availability. Right now, in front of you is a satellite image of the Ahmedabad region. And in this particular one, you can see lots of colors, textures, different types of lineaments, etc. But if you know how to interpret between these colors, how to interpret these elements, then it would be really easy for you to understand what is happening. So in this particular case, the easiest way to understand is that wherever you can see the red colors, most of the cases, I'm not generalizing, but most of the satellite images, the red colors denotes the vegetated lands. That means wherever you can see the red patches, these are the vegetated land. You can ask me, why is it so the red color is applied for the vegetation? Because it is having the highest wavelengths, and it is going to give you the proper idea where the vegetation is situated. You can use different color scheme also, but most of the cases, the red colors are used for that. Other than that, if I'm talking about this bluish color, they are mostly used for the settlements. Wherever you can see the black colors, that is more or less water body. If the black color is dark peach, that simply means it is more or less it is transparent. But if it is not that much dark peach black color, that simply means it is having certain kind of impurities. Right now, the image that is in front of you, it is the LIS 3 sensor image with a resolution of almost 24 meter resolution, which is quite good. Now, if I'm talking about the LIS 4, obviously, it is showing same thing, but its color scheme is totally different. Here, the color scheme is false color composite, where the specific color is not used for that particular element to distinguish it properly. But here, I have chosen this image because to show you that actual color can also be used for the satellite image. Where this green color means we are talking about the vegetation. For these black regions, this bluish color water body, that is showing the water region. Or this grayish color or the yellowish color, these might be the open exposed land. It is also possible to use, but it depends upon your need, what type of problem you are dealing with. You can use those kind of color schemes. Now here we have used the temporal variation. We are trying to understand how things change over the time period. The left-hand side satellite image is of 2005 and the right-hand side satellite image is of 2011. And you can see there is a considerable change between both. For example, this most important thing that you can observe is reddish color. In these years, the recent year, the reddish color is increasing. The depositions of the coastal areas, they are also increasing. As I have told you, most of the cases, red color shows the vegetated land, and here we are concerned about, or we are considering the mangrove regions of this particular region. So that means if you want to see the temporal variation over the time period, satellite images plays a very important role. And this is same for this particular one, but here we are having relatively higher resolution satellite image, where you can see this one and this one. Obviously, you can see that it is having a much larger information, much larger depth, and the objects in the images are really, really clear. It is a Landsat 3 satellite image, and it is packed with information. That is why we, most of the cases, rely on a higher resolution images. But problem is that it is not always possible to have all the images of the particular region. I'm going to talk about the problems in the coming slides. It is another type of satellite image where MODIs, that means it is a moderate resolution satellite image where the resolution is quite coarser. You can see the dust is moving from the parts of the Patagonia, or the right hand side we are having a hurricane type of feature which is just in the process of formation. That means the tropical storm that is coming. That means if I'm talking about this particular satellite images, their purpose is totally different. Here the resolution is so coarse we can see nothing. But in the previous one, we can see these particular land parcels, or we can see the vegetated land, or we can see smaller patches, but here it is not possible to see. Then why we are using it? Because our purpose is different. Here we are not concerned about what is happening on the land surface. Here we are concerned about what is happening at a macro scale. That is why we have chosen different type of satellite product. The top here, the Kalpana satellite image is our India's satellite, where it is actually useful to show the climatic variations, water vapor, cloud cover of the particular region. For example, this is a recent photograph of India. And you can see right now the availability of the cloud is mostly found nearer to the eastern coastal region. Other than that, over the West Bengal, we can't see any significant amount of cloud cover. So that means this particular type of images are so good to give information about what would happen in the next 24 hours. So there are other products also. For example, we can have digital elevation model, or we can have different type of thermal images also. Their uses are totally different. For example, I think you have seen in your college classroom this type of elevated or this type of 3D models physically, but in computers we can have them virtually. There's a certain model that they are DM, digital elevation model of the particular region. Or we can say have thermal product. For thermal product means we want to see how much energy, how much heat is generated from a particular region. You can see the colors shows the intensity of the heat of the particular. It's actually taken in the specific region of the electromagnetic spectrum, the infrared that I was talking about in the previous slides. Now, when we have completed it is the basics of the remote sensing. Now we can jump into the GIS, that means Geographical Information System. So one thing that we can conclude from the discussion of the remote sensing is that remote sensing is a platform through which we can collect the data. We can procure the data according to our need. Whatever problem you have, what kind of problem you want to deal with, what is the intensity of the data you are talking about, based on that you can collect the data. But after collection of the data, what we are going to do? Obviously, we are going to process it. We are going to process it to have better outcome from that. So Geographical Information System, or GIS, it is a kind of platform where we can do this type of work. In the simplest term, what is the meaning of GIS? GIS is a type of platform where we can merge spatial as well as spatial data or the attribute data. Let me explain to you what is the meaning of attribute data or the spatial data and spatial data. Spatial data means which is having a spatial extent. Let's say a map. For example, map of India, or let's say the different state-wise that map showing the state boundaries of India. Now, what I want to show, I want to write the name of the state inside that particular state. Now, you need to understand here, writing a name, it is a kind of attribute to that particular region. So that means the platform where we can join this spatial map, that means this of India with the name of that particular state, and we can join both of them. That is the work of the GIS. But obviously, that is not only the work of the GIS, that is the beginning through which we can understand the process of GIS. So what are the different components of GIS? First, data, pre-processing, data management, manipulation and analysis. Now, what is the meaning of manipulation? I'm going to discuss about in a few next few slides. Analysis, product generation and visualization, and decision making and the policy making. Let me show you one slide through which you can understand. Let's say this is the entire gamut, entire process of the GIS, where we need people, we need software, we need data, we need different type of approaches as well as hardware. When we are going to merge all of them, then we can work in the GIS platform. Sometimes it is a very wrong notion that GIS is only a software. No, GIS is not a software. Next important notion, very wrong notion about the GIS software is that GIS is all about producing colorful maps. No, colorful map generation is not only the objective of GIS. The objective of GIS is much larger than that. I'm going to discuss about it. Now, if I'm talking about the GIS, how it works, let me give you a glimpse. Suppose you are having 5 transparent sheets with you. On first transparent sheet, what you are going to do, on let's say you have a topo sheet. I think you know what is the meaning of topo sheet. You must have worked on the topo sheet. Let's say on one transparent sheet, you are tracing the vegetation cover of a specific region of that topo sheet. Now you are keeping it aside. Now you are putting another transparent sheet on the same region. This time you are not tracing the vegetation cover. This time you are tracing out the roads of that particular region. You are putting it aside. Next, you are putting another transparent sheet and you are taking out all the settlements present from that particular region, and so on and so forth. You are taking one element at a time and you are putting it on the transparent sheet. Now what you are doing? You can take all the transparent sheet at once and you are trying to see how it looks. Now, if this transparent sheet work is done in the computer and you are making permutation and combination of different types of layers depending upon your needs. That is the basic functionality of a GIS, where we works on the layers. In physical form, we are calling it transparent sheet. In virtual form, we are going to call it layers. You can have n number of layers depending upon your need, and based on your need, you can different type of combinations. For example, in this particular slide, you can see we are having roads and settlement, and you are having contours of the topography. Now, if you are trying to understand how they are related with each other, you can take these two only. But accordingly, you can add the different types of stream orders or different types of drainage of that particular region, or you can use different type of vegetation cover, you can use different type of settlement, and so on and so forth. You can merge all of them, and depending upon that, you can make your own decision which area would be feasible for making any kind of further development. Then let's say that is our main objective. For that, we need to take n number of layers, and based on that, we can make our own judgment. Now, if I'm talking about the data, as I was talking about spatial as well as attribute. When we are talking about the GIS, we are having both the data, like spatial as well as the attribute data. Now, spatial data means which is having a spatial dimension. Let's say a map. Now, in computer, or when we are talking about GIS platform, this spatial data is having two types of character. It can be a raster, it can be a vector. What is the meaning of raster format? Just think about the photograph just you have taken through your mobile phone. In that particular photograph, you can see yourself, you can see the background, you can see whatever is happening around you. And how is it possible? Because yourself is different from the background. How is it different from background? Because your information of your face is different from the background. And what is this difference? This difference lies in the pixel values. Every image is associated with a specific pixel value, which is also known as DN, or the digital number. And this digital number is always going to be different if the object is different. And that is how we are going to differentiate between two objects. Let me show you another picture slide where you can see I have given different numbers. These numbers are the DN value, for example, and you can see based on these differences, we can have different organizations. Wherever you can see 50 values, you can see single color is there. Wherever 67 is there, we are having similar color. In that way, we are having different colors based on different types of values. Now, what is happening here, whenever we are going to get this type of DN values, our processor is going to create that type of image, which is going to show you the object. Whenever this DN value, this reflectance is going to change, obviously the object character is going to change. Now, if I'm talking about different formats, let's say JPG, PNG, TIF, these are the type of raster format that we usually acquainted with. For example, whatever photograph you are taking through your camera, most probably it is in the JPG format or the TIF format. But there is another way or another format in the spatial aspect of the GIS that is known as the vector format. Vector format means here the raster format means simply the pixel values or the matrix of cells of a specific image. But in case of vector format, we are having certain advantage. What is the advantage? Let's say we are having a photograph today and you are trying to zoom it. And after certain zooming, you find that the image is pixelated. But you don't want that. You want that particular image, whatever the level of zooming is there is no pixelation. So what you can do, you can have another format that is known as the vector format. The vector format generally works in terms of the geometry. For example, if I want to make a map, what are the different things I want? I need point, I need polygon, and I need lines. Through point, we can show different locations. Through lines, we can show different streams or roads. Through polygon or area, we can see land surface or the water bodies. That means when we are talking about the point, line, and polygon format in GIS segment, we are talking about the vector. The specialty about the vector is that It is how much you are going to zoom it. It is not going to pixelate over the time period. But what are the different types of your file extension? It can be DXF, SVG, EPS, etc. But major issue with the vector format is that it is very, very complex type of dataset, and handling this type of dataset will also need certain expertise. Likewise, this point feature, these line features, these area features, they are known as there comes under the vector type of datasets. Let's say in this particular map we are having a tree, and that particular tree obviously going to be a point feature. Here I have shown you through a symbol, but on the map I'm going to put a dot, and that dot is going to show you the vegetation, and that is the attribution to that vegetation. Now line feature, for example, this road, obviously this is not going to be a point feature. This particular on this map it is going to be a line feature. Likewise, let's say we are having a lake here. This lake is a kind of area feature. So that means if I'm having point, line as well as polygon or the area, we can make maps in the GIS environment. So attribute data means that I was talking about. Let's say I am making this particular polygon and I want to write the name of this particular lake. Let's say Thompson's Lake. Now writing this Thompson's Lake needs certain place where I can type it. I can type these alphabets. It can be like Thompson Lake 29 also, which would be alphanumeric, whatever it might be. So that means when I want to attribute the spatial aspect with certain things, then it is considered as the attributions or attribute data. So attributes means it is a kind of alphanumeric, that means alphabetic, numeric, or a combination of both information about the spatial extent, then it would be considered as attribute data. Now, let's have a look at different softwares in GIS. We are having n number of softwares. For example, right now AutoCAD is becoming so popular that it can handle the aspects of the GIS also. We have microstations, we have ArcGIS, we have MapInfo, ADAS, QGIS, ArcGIS Pro, ILWIS, and so on and so forth. We have Idrisi and so on and so forth. So many softwares are there. But question may arise, why is it so that in the market so many softwares are there? There is a reason behind it. Now, let me tell you, yes, in this entire thing, this ArcGIS or ArcGIS Pro, they are the leader, or they are having some leading positions in the GIS industry. It is having some historical background also, but they are having a very strong base. Now, if I'm talking about the GIS hardware, so obviously we need hardware to work. For example, we need PC, we need printer, plotter, scanner, digital data acquisition systems, and so on and so forth. And finally, we can process both of them. And basic aspect about these things is that we need a software, we need a hardware, we need people, we need approach, that is we need understanding, and then we can sit together to work on the outcomes that is coming out. Now, this slide is there, and I think you are quite acquainted with this particular thing that is known as Google Earth and Google Earth Pro, where it is a kind of product of the Google, where we can see the Earth surface and we can see time lapse also. We can see certain other dimensions like state boundaries, district boundaries, even the other road lines, elevations, and so on and so forth. Now, if I'm talking about the basic things that you can do in GIS, it can be a georeferencing. What is the meaning of georeferencing? It can be a digitization. It can be attribute data entry and further mapping. But before that, before doing anything, we need to have a base map. What is the meaning of base map? Base map means on which we are going to start work. Base map should have a specific character. It should have a latitude and longitude. Without lat and long, it would be really difficult for us to move ahead. What is the meaning of first thing? That is georeferencing. Georeferencing. That means referencing something to the earth. That means when we are talking about a map, let's say this map, it is a piece of paper that we have just scanned. Now, computer is not knowing we are talking about which place. So we need to give certain coordinates to the computers. in terms of this particular map. This particular process, that means this is the process of adding coordinate information to the digital image so that it can accurately deployed on the map. Then it would be known as the georeferencing. That means simply means that this scanned map, when you are going to putting into the computer, we need to tell computer, yes, this particular map belongs to this particular place, and for that we need to add coordinates. Coordinates means in terms of latitude and the longitude, and there is a certain process. Let's say I have used, this is a slide showing the QGIS environment, that is a software of the GIS, where this particular map is having coordinates like this, latitude and the longitude, and through a specific process, let's say at point, we can use the latitude and longitude in terms of the east as well as the north. Then afterwards, you can see there is a point and the computer is showing that the X coordinate and Y coordinate is 70 as well as 15. That means 15 degree north and 70 degree east. And likewise, in case of the georeferencing, we need at least 4 points or more than 4 points. So here you can find 5 points. Afterwards, you can just process it and you can make the georeferencing. And when the map is georeferenced, further you can do whatever you want to do. For example, I want to make a map of South India or the southern portion of Indian, that means Indian Peninsular region. So what we can do, the next thing after georeferencing, that is known as digitization. Digitization means simply you in your practical class, when you did the topo, that means the light tracing, the same thing is happening here. That means at the back side, we are having the georeferenced map, and in the front side, we are trying to trace it through the digital, any kind of digital machines. It can be your mouse, it can be digital pen, or so on and so forth. That means they are based on that particular aspect. When you are going to digitize the region or trace the particular aspect, then it will be known as the digitization. So digitization simply means it is tracing out, but obviously without georeferencing, it is not possible. Okay, I'm not going to move into too much into the projection, but let me tell you, when you are talking about the GIS, projection also plays a very important role. Without understanding of the projection, it would be really difficult and it would be really troublesome, because projection is very important aspect. Next thing that we can do, it is known as the interpolation. What is the meaning of interpolation? Let me tell you. Let's say this is one of my study area where these points are showing the soil sampling locations. And what we did, we have collected 76 soil samples from this particular area. And let's say we have analyzed pH value of the soil. Then what we did, we use it in the GIS environment. So these points are these points are there as a vector data, as I have told you. And corresponding to this particular point, obviously, the attribute data that would be there in terms of the pH value, they were incorporated. And afterwards, when we use the particular aspect in the GIS, let's say interpolation, that we are trying to understand which area is having more than 7.81 pH or 7.4 to 7.8 pH or less than 7.4 pH, then this type of maps can be generated. They are very easy. That means we need to just click there are a few clicks and you can generate this type of map. And these classes, here we have used 3 classes. Depending upon your need, you can use 5 or 10, whatever class you want, you can use it. Now, the other aspect that you can use in the satellite, in the remote sensing domain, that is very popular, that is known as land use and land cover mapping. What is the meaning of land use? Land use means how we are using the land. For example, agricultural land. Land cover means how the land is covered. For example, snow cover, water cover, whatever it might be. Now, in this particular paper, what they did, this is the satellite image, and from this satellite image, we want to map it. That means how much area is vegetated, how much area is having water body, how much area is barren land and built up area. So for that, what we need to do, you could do land use and land cover mapping. That is also possible in the GIS environment. That is also, I'm going to show you in the next few examples. The brief understanding of the global positioning system. I want to tell you that this GPS plays a very important role nowadays, because when you are talking about the data collection, if I am going to the field and if I want to mark that particular position, and when I'm moving back to my base and I want to plot it in my computer, GPS are indispensable. Nowadays, in your mobile phones also the GPS are there. These are traditional handheld handheld GPS. There are other very expensive type of GPS. They are known as the DGPS or the differential GPS. Their uses are totally different than the handheld GPS, because handheld GPS are mostly having error. It is having error of 5 meter or so. But when we are talking about the DGPS, their error limit is very, very low, almost about only a few centimeters. And now it is Trimble. A few days back, I was looking at a specific model where the error, that means the error of that particular instrument is so low that it is like anything. It's the process of the GPS, that means how the GPS works. It is very easy. If I'm talking about the normal GPS, we need at least 3 GPS satellites at a time, and it is going to send the information to your handheld machine, and based on the interpolation, it is going to give you the exact location where you are standing with certain amount of error. But when we are talking about the DGPS, the working principle is totally different, where it is not like that the satellites are directly sending the information to the handheld rover or instrument. It is sending the information to the particular antenna that is there on the Earth's surface somewhere, and our rovers, our handheld machines, they are calibrated with that particular antenna through which we can take the information. That is the basic difference between the DGPS as well as GPS. Now, India recently, that means the GPS word is not of India. It is, that means when you are talking the US, they are mostly using the term GPS. But right now, India is having the same system, but its name is IRNSS. That means Indian Regional Navigation Satellite System. We are having 7 satellites that is providing us the information regarding the locations. So if I'm talking about the Indian aspect, it would be known as the IRNSS or in NAVIC. But if I'm talking about the US product, that is known as the GPS. So now we comes to the application parts. Now, if I'm talking about a problem, let's say we are having an issue that we want to solve. We need 3 aspects right now. Number 1, we need the help of remote sensing. We need the help of GIS. But afterwards, when we are talking about the interpretation or we are talking about the application or the analysis, we need certain type of tool that can handle those kind of outcomes. That is the aspect where we are discussing about the geostatistics. And now we're talking, if I'm talking about that very aspect of the cloud-based remote sensing. Now, question may arise why there is a concept of cloud-based remote sensing and GIS, and nowadays everything is in the cloud. But basic question is why we are so much concerned about the clouds, because our basic understanding of the remote sensing is associated with the 2 important things, that is software as well as the hardware. Let me tell you, the remote sensing softwares or GIS softwares, they are really, really expensive. At the same time, over the time period, the availability of the data, the amount of data is so much that your PC, your computer, is not able to handle, because otherwise you need to increase the capacity and you need to spend a lot. So keeping in the mind of this particular constraint, now we are focusing on the cloud. That means whatever the configuration of your PC might be, obviously to a certain limit, you can use this cloud platform to process those data. That means this processing is not actually happening in your PC. If the processing is happening somewhere else, you can just give the command, and this command is performed in a very high specifications computers. So that is the basic ideology behind the cloud-based remote sensing and GIS, and this is the basic architecture, how it is happening. That means we are here, end user, and through internet we are interacting with the cloud, and there are so many things happening behind that obviously we are not so much concerned about, but they are very much important. One layer is the associated web server category, web server map, web processing, etc. As well as we are having data repositories, spatial database, and we can interact with each other at any point of time. And that is so easy that nowadays these static softwares on the hardwares is becoming obsolete. Over the time period, it is predicted that by 2050, most of the 99.99% aspects of the processing would be done in the cloud, because they would be really, really cheap, and they are going to be much more feasible than having very high-end computers at your home. Now, one of the important example of cloud-based remote sensing is Google Earth Engine. Now, let me tell you, it is Google Earth Engine. It is not Google Earth. Google Earth Engine is a kind of product of the Google, which is cloud-based remote, where you can do all the aspects of the cloud-based processing and the GIS work. I'm going to show you one example that I recently worked on the Google Earth Engine, and I'm going to show you. This is the basic window associated with the Google Earth Engine, where we are having three boxes at the top, where this particular at the left we are having scripts. Scripts means here we are going to write the commands. Obviously, Google Earth Engine, it is not a graphical user interface. It is we need to write certain codes, but they're very easy to understand. If you sit for 1 hour or 2 hours, it will be really easy and you would understand what is happening behind. So what is happening here, we are having scripts. That means whatever file you have generated, they are going to be here. You are having different docs. That means this is the part of the Google Earth Engine. That means whatever you are going to use, let's say you want to call a satellite image, then there is a particular term or syntax for that is stored here in the docs. That is not, you need to not to do anything here. Assets means here you can upload your own shape files. For example, you have created your study area map and you want to work on that particular area only. From assets you can upload those things from your computer to the Google Earth Engine. Here the central part, you can write down your codes, and accordingly you can process it, like putting the run. Here we are having run button, and you can just click on it, and accordingly this particular console will show you what is happening here. This is a work that I recently done near to in the Rajasthan region, and I'm going to discuss about it in the next few examples. Now there are different. Now let's focus on the applications. That is the last aspect of our remote sensing and GIS detection. The first example is of the detection of the temporal variation. Let's say this is a particular part that I want to that I have worked. That is the part of the Gujarat, and we have mostly focused about the Skori Creek region. What was our objective? And these are the certain course locations which was associated with different types of coring. That means we have collected vertical continuous sediments from these particular regions. The geologists did that work. My work is to map this particular region. The major trouble or major challenge was that this particular region, that means what we did, we have taken images of 1984 and 1994 and 2014 and 2020. What we are trying to understand, how these creek region has changed over the time period only from 1984 to 2020. The major issue is that in 1984 only the available satellite images were Landsat images, but in 2020 we are having very high resolution satellite images like Sentinel. Now, when we have started working on that means when we have started digitizing this particular region, what we felt that this digitization work is going to take a lot of time. But when we are going to move it to the Google Earth Engine, it was so easy you would not believe, because the Google Earth Engine is not going to work in isolation or in a very traditional method. We need to just give it certain commands, and it can just extract the information from that particular region. So in this particular one, you can see easily that this particular part, that means here we can see a U-shaped, that means this meander-like feature. And in the recent year, you can see that meander feature is totally eroded. And here you can see these channels were so narrow, but over the time period, it is becoming so thick. That means over the time period, we want to see how the change is happening in terms of the temporal dimensions in a spatial region. Now, if I'm talking about the time series data, that means if I'm talking about very long-term data, 2020, 2021. Now, let me put it into the perspective. This is the study area where we are talking about the arid and semi-arid region of Rajasthan. It comes under ACZ2 agroclimatic zone, where what was our major concern? What we actually were trying to understand? Let's say this is the two satellite images, or in terms of not satellite, these are the NDVIs of our study area. It is the NDVI, that means normalized vegetation difference index. That means we are trying to see what is the vegetated land of this particular region. And you can easily observe that in both the regions, the vegetation coverage has increased, like a considerable increase of vegetation cover can be observed. Now, the objective of this work was to understand if we are talking about the precipitation, if I'm talking about the soil moisture, evapotranspiration and temperature, over these 21 years, over 20 years, how these parameters affected the vegetation. That was our objective. Now, if I'm talking about this correlation thing that you must have completed in your practical class, this correlation matrix can show you where the correlation was much higher, where the correlation is weaker, where correlation is not there. This is a simple Pearson correlation matrix. But the problem is somewhere else. Now, if I'm putting all these data into a linear fashion, only you can see in case of NDVI, these best fit line showing some positive trend. But just look at the other lines. There is no significant variation over the time period. But the vegetation coverage obviously has increased in an arid region. That means something is happening and we want to understand it. But here we have used some kind of statistical tool which is quite able to extract that particular. What we did, we have used wavelet analysis. What is the meaning of wavelet analysis? Let me put it in a very simple way. Correlation is having one major drawback is that correlation can tell you whether correlation exists or not, at what level relation exists or not, but correlation time the correlation or the coherence was much stronger, at which point of time it was much weaker. Wavelet can do that particular thing. So what we have used one software that is also open source software that is known as RStudio. You must have gone through also. It is open source software. You can download it, and when we have run that particular aspect on the RStudio, we got this particular outcome. Let me show you. Let me tell you what is the meaning of this particular diagram. Here, the x-axis shows the years. This is 2001 to 2021. And the y-axis shows the period of the months, second month, fourth month, sixth month, eighth month, and so on and so forth. We have used continuous data. And what we are trying to understand, we are first trying to understand the coherence between precipitation as well and NDVI. That means whether precipitation is having any coherence with the NDVI or not. And here these red patches are simply showing the coherence period. That means in this particular period, the coherency was there. And in those areas where the intensity of the red color decreases, the coherency was lesser. Another thing, you can see certain smaller arrows are there. These arrows shows which parameter, whether these two parameters were in association with each other or not. If the arrow is towards eastward side, I'm not going too much detail into it, but trying to convey what is the meaning of this arrow. If the arrows are showing eastward directional movement, that simply means they are almost going hand in hand. That means precipitation and NDVI moving in a more or less similar pattern. Precipitation increases, NDVI also increases. But if the arrow is moving in the opposite directional movement, that means it is somehow towards the left, it can be south east, or it can be southwest or the southeast, then that simply means both the parameters are not going hand in hand. Just look at this particular region where smaller arrows are moving in the southwestern direction. That simply means this particular region, this particular period, that means 6 months of 2021, where coherence was there, no doubt about it, but the temperature and NDVI both were not having significant coherency with each other. Let me tell you, this the beauty of this particular software, that is our software, is that you are, by writing few lines and changing few parameters, you can work with it, you can play with it, and you can have your own type of outcome. Because whatever you are doing in the Excel, you can do it in the R with much more efficiency with lesser time. But it is again a code-based work. You need to give it some time. Afterwards, it would be really easier for you. Now let's talk about the agricultural aspect. That means let's talk about application on agriculture. You must have done like crop combination, crop diversification, agricultural efficiency. These are the basic things that you can work on this particular GIS platform also. Where what we did, we have prepared a map of Rajasthan, and here we are having different districts like Barmer, Jodhpur, Jaisalmer, and we have incorporated the value of the agricultural efficiency as attribute data, and based on that we have classified the images of two times, 2008-9 and 2021 and 22, and we have tried to understand how over the time period the agricultural aspects in terms of the efficiency, in terms of the diversification of the crop combination has changed. Now, next one is known as the multi-criteria decision making. What is the meaning of multi-criteria decision making? When the decision that you are going to take is based on multiple factors, then it would be known as multiple decision making method. One of it is known as AHP, Analytical Hierarchical Model. What is the meaning of this? Let me explain it so that it will be really easier for you. This is the study area that we worked on, and we are trying to understand in this particular area which part is going to have better bajra production. Based on what? Based on certain criteria. That is what I'm trying to see in which area, if I'm going to grow bajra, we are going to get best out of it. So what we did, first we have selected certain criteria. For example, mean temperature, rainfall, slope of the land use, land cover, soil texture, and so on and so forth. From where we have selected these type of parameters, there is a book produced by ISAR, Jodhpur, and we have taken the information from the professors as well as the farmers. Professors means those who are engaged in agricultural geography, agricultural science for the past 20 years. We have asked those questions to them, as well as we have asked those questions to the farmers of that particular region. So after selection of the criteria, what we did, when we have asked so many questions, then we have averaged the criteria specific opinion. Whatever opinion we got, we have just averaged them. And finally, we have processed the data in the ArcGIS, in the GIS environment. And based on that, the GIS told us that mean temperature is going to have this percentage of impact on overall growth of bajra. Total rainfall is going to have this much of percentage of impact on the growth of the bajra, and so on and so forth. That means from here, we can understand which parameter is going to play a significant role in growing a specific crop in a specific region. After that, when we are going to overlay all the layers in the GIS environment, we got the final outcome where based on that, we can classify that means highly suitable region, moderately suitable region, marginally suitable region, and not suitable for that particular production. Next one, that is a bit more advanced one. That means we have used large data set on the Google Earth Engine. I'm not going to explain this right now, but I'm telling you the basic necessity of the Google Earth Engine. Let me just put it into perspective very quickly. Suppose you are working on an area where we need 20 satellite images. That means combining 20 satellite images, you are going to have the entire region. Now, what is the total size of these 20 satellite images? Let's say 20 GB. Now, you are working for 20 years and monthly. In 1 month, you have 20 GB. In 12 months, 20 GB multiplied by 12. For 20 years, 20 GB, 12 months, 20 years accordingly. So you can see the volume of data that is going to be generated after processing. And sometimes, most of the cases, it would not be possible for our own local machine to handle those kind of high-end data sets. So for that, we need Google Earth Engine like cloud computing GIS platform. And that is very easy to just work in the Google Earth Engine. Again, there are all the free resources are available. And if you go through that, you can just look at it. This is the modeling that we did, and this is a similar type of modeling that we can work in the groundwater aspect. Where what was our major objective? Our objective is to understand what is the potential pollution zone of the groundwater. For that, what we did, we have collected different parameters: depth, recharge, aquifer media, soil media, topography, impact of the water zone, hydraulic conductivity. These are the parameters. And if I'm talking about the notations, each first letter, if I'm going to take, it is called DRASTIC, that is drastic. This is the hydraulic conductivity, means we are talking about the conductivity of that particular, it would be there in the C, that means drastic. Now what we are going to give it, we are going to give some weights to that. For example, let's say depth to the water, it is having the weight of 5, that is maximum weight. Net recharge 4, aquifer media 3. That means every parameter is associated with that weight. Again, it is associated with the rate also. That means if the depth is less than 5, its rate would be 10. If its depth would be 5 to 15, its rate would be 9. If it is more than 15, it would be 7. So that means what is the equation? dr/dw. That means when we are multiplying the depth with the rate, depth with the weight plus recharge, again these type of equations, then we are going to get final drastic model. This is the outcome of the drastic model, where we can see each colors, that means these zonations are there, and this is aspects of the other parameters are there, and just few applications also, more or less they are the same. I want to just conclude my discussion with one of the emerging areas of the GIS, that is artificial intelligence, artificial neural networking, and new dimensions. Now, just let me put it into perspective. That means, what is the meaning of artificial intelligence? Intelligence means whatever is there in your brain and whatever is needed for performing a process, that is known as the intelligence. Human brain is having 10 billion neurons and they are working parallelly. But if I want to mimic it, what we are trying to do now, our computers are trying to mimic that, and through which we are trying to create, or we are going to make certain decisions, that is known as the artificial intelligence. For example, right now in the market, you are talking about ChatGPT, you are talking about BART, you are talking about Copilot, and so on and so forth. We are trying to make these kind of things incorporating into the system so that human efforts can be minimized. But you need to understand, ChatGPT is not going to kill the market of the GIS. It is going to, there are different other things, there are the different other dimensions which would emerge through that. What ChatGPT is doing, ChatGPT or any AI tools, they are just saying, focus on your work. Rest of the things, just leave it on us. We are going to provide you. You need not to waste your time on that. You need to focus on your objective. That is what AI tools about. So, for example, this type of thing where it can be very complex algorithm also. So the conclusion is so many things, so many projections, so many coordinates, so many methods, so many softwares. Now, question is, which one should I use? How to express it? Where can I locate it? Are they really required? Is it necessary to understand the mathematics behind the concept? The answer is on the problem. And the 4 things that we can conclude with which we are the 4 quotes, or the 4 things that is very much important to understand before starting any work in the GIS and the remote sensing platform is, what is or are my problems? What I want to do, why I need to study it, how to solve the problem conceptually, where can I find the constituents. So we can conclude with the very famous quote of Einstein, that is, I don't need to know everything. I just need to know where to find it and when I need it. Thank you.
Thank you. Thank you, sir, for your valuable deliberations. I am sure that our students of both of our institutions will be benefited by the knowledge sharing through today's lecture. Now the session is open for discussion. I first requesting our faculty members to say something about the lectures and their observations, if any. Please. If then okay. If there is no such observations from our faculty end, I want to share a few questions which has come from our student end.
Sure.
Can I share, sir?
Yeah, please.
Okay. Sir, the first question is how can we assimilate AI and ML with the geomatics, and how this can be useful for the academics and research under the domain of geography?
Right.
This is the question number one. Question number two. Question number two, what are the prerequisite conditions of the Google Earth Engine platform, and what are the advantages?
Okay.
I think you have already shared about this in your lecture, at the end of your lecture in a few minutes, but the question is there. And number third is, what is the actual potential of learning only the open source software in the commercial market, as we the students are normally learning the open source software in UG and PG levels.
Okay.
And the market value of the UG PG level learning.
Sure.
So can you please answer?
Yeah. So the question, the first question that is very important, that means when you are talking about machine learning or AI in geography, let me just take 1 minute. Just let me show you something. Just I skipped that particular slide due to just a minute. Let's say this work that is actually under review right now, so I can't tell you everything about it, but let me tell you how we have used artificial intelligence in geography. That means this particular work is associated with number of groundwater parameters, for example pH, EC, and so on and so forth. Now what we are trying to understand, we know that water quality index, it is a well-known process or well-known method through which we can understand what is the potentiality of the groundwater of that particular region. Now, if I'm asking, or after getting the result from the this water quality index, now if I'm asked the artificial intelligence or any other black body kind of instrument to tell us what is your opinion about our outcome, then that is going to re-verify what is about, that is going to verify the results. In this case, we have used the most recent artificial intelligence tool that is known as explainable artificial intelligence, or XAI. Initially, what happened? These AI or the machine learning tools, they were more or less black body or black box, or whatever is happening within that particular thing, we don't know. But this explainable artificial intelligence will tell you what is happening underneath. For example, this is the water quality index map, and we have asked the same question to the artificial intelligence, and this particular graph clearly tells us what is happening. Now, in this particular case, water quality index tells us that this western part, northern segment, and the southern segment, there are few patches of a relatively that means central portion is having better quality groundwater, while the other segment is having not that good groundwater quality. Now we don't know that which parameter among these are playing significant role in controlling the groundwater quality. It is very difficult to say. So that for that purpose, when we are using artificial intelligence, it tells us this is fluoride, TDS, they are playing significant role in controlling the water quality of the particular segment. Through the traditional methods, it is really difficult to figure out that means which parameter is responsible for how much of the pollution of this region. But in case of this artificial intelligence, the algorithm is so good that they can make out of it with relatively lesser error. This paper is actually under review. So this much I can tell you, that when you are talking about the machine learning, when you are talking about the artificial intelligence, the thing that is there is it is going to verify your outcome with the perspective of a machine. and with a certain limitations, obviously. And you need to train the machine accordingly. As the training is going to be better, the outcome would be better. That means the verification level would be much better than that. This is the answer of the first question. And second question, that means the Google Earth Engine that asked question is asked. Just let me show you how what is the advantage of Google Earth Engine. Just a minute. This is the Google Earth Engine, and what are the basic requirement for the Google Earth Engine. The first thing that you need to register in the Google Earth Engine, and for that you need they are going to take 1 or 2 days to active your account. You can use your own Google account for registering in this particular domain. After that, you can just log in into your basic window, and here you can see I have prepared few scripts, and among that, let me show you one. These are the scripts that I have created, and here in the central segment, you can observe how the script actually works. And this is the script. Sometimes it is really difficult for us to gauge the script, but let me tell you, if you are acquainted with it, it will be really easier for you. Let's say this first line, 2020 4th of January, February, April 1st to 2020 4th 15. That means for a 16-day image, I have taken in a specific variable. Let's say call 1. That means in this particular A parameter variable, I have assigned this particular images. That means 16-day images. Now, if I ask you to download 16-day images of this Sentinel, it would take long time. It is going to take much space in your PC, and its processing is also very difficult. But when it is really not possible. And let me show you how many images we have called. It is actually for 1 year we have called the images. That means all these images are Sentinel images. They are 10-meter resolution images. They are so high resolution. So if I'm going to do this in a normal computer, normal PC, it would not be possible. And afterwards, what is the advantage of it? Whatever outcome you are getting out, let me just run the code for you. For example, when you are going to run it, it is going to take some time, and it is going to give you the outcome. See here, the layers are processing. This is the part where we can see the console where the image is processing, and these are the layers that I have created. How many layers I have created? 3, only 3 layers we need. So we have created 3 layers. So classify it. This is the NDVI layer. That means all the layers we have stacked together, and this is the NDVI layers. And afterwards, we have classified these red patches are the layers with the higher level of NDVI, where these blackish or the darker areas, they are relatively lesser. This is the final outcome of all the combinations of the images. We can say this is the land use, land cover aspect of this. And these red patches, they are the Bajra regions. That means these are the growth of the Bajra. Maximum Bajra is growing in this particular region. And when we have just picked it in terms of the land use and land cover mapping, where we ask the Google Earth to just classify these red patches as the Bajra and the gray patches as not Bajra, then we are going to get the right result out of it. So this is the whole result that we are getting from the Google Earth Engine, and it is totally free. And you can do whatever you want to do, whatever you can do in your AirDAS software. But obviously, it needs certain time to acquaint with this type of things. And the answer to the third question, that is the acceptability of the open source software. See, I have started my journey in the field of GIS and remote sensing in 2009, and I was very much fascinated about a software which is called obviously ArcGIS, and I have started my journey from ArcGIS 9.2. And let me tell you, the starting of the journey is really painful. You would find lots of difficulties. But nowadays, when I see a software like QGIS, that is also open source software, it is having so versatile tools and techniques available. Now the Google, that means this ArcGIS is also becoming, it is there in their process that over the time period is also going to be open source software. So I'm going to tell you that what type of software you are learning about, what is the software you are using right now, that is auxiliary. You should have the capacity to solve the problem. And for that, you can choose any tool, any platform, whether it is a Google Earth Engine, whether it is Airdus or whatever it might be. So this is my opinion. Just focus on the problem, not on the tool. Tools are very easy. You need to just click. There are a few clicks or few lines, nothing more than that.
Thank you. Thank you, sir. Thank you for your elaborative answer. Now, I'm requesting, finally, we have come to the end of today's program. I'm requesting Professor Debabrata Chandra, our HoD, Department of Geography, Asutosh College, to give the vote of thanks. Debabrata, please.
Thank you, Subhadeep, sir. Subhadeep, am I audible?
Yes, audible.
Okay. Respected GB member, our senior faculty member, Dr. Saini Mukhopadhyay, Honorable Speaker, the faculty members of Geography Department, Balurghat Mahila Mahavidyalaya, our departmental colleagues, and my dear students from both colleges. Good afternoon to all of you. We have reached at the end of this program. I feel honored and privileged to having an opportunity to offer vote of thanks in this webinar program. First of all, I would like to express my gratitude to our principal, Dr. Manas Kavi sir, the IQAC coordinator, Dr. Sravani Roy, the principal of Balurghat Mahila Mahavidyalaya, Dr. Biman Chakraborty, and the IQAC coordinator, Dr. Kiran Sunar, and obviously the MO committee for giving us this opportunity to arrange such kind of faculty exchange program in the form of webinar. I would like to express my sincere gratitude to our Honorable Speaker, Dr. Tathagata Ghosh, for delivering his outstanding and informative lecture on fundamentals and applications of remote sensing and GIS. I must mention our deep sense of appreciation for his explanation, demonstrating the topic, and sharing his knowledge and experience with us. I must say, your lecture will definitely help our students to enrich themselves in this context. Thank you, sir, for giving your valuable time to us. Now, I will express my thanks to all the participants who have joined here or who have joined in this webinar program. Without your participation, this program would not have been successful. So thank you for joining the webinar and paying your valuable attention in this program. Finally, I would like to offer the thanks to all the faculty members of Geography Department, Balurghat Mahila Mahavidyalaya, my departmental colleagues, and obviously all the students for their cooperation to make this program successful. Thank you once again. Have a nice day. Okay, thank you.
Thank you, Debabrata. With these kind notes, I am concluding the webinar. Thank you, Tathagata sir. Thank you all.
Thank you.
Thank you.